Hello, my name is Dan Turner, and I'd like to welcome you to the introductory session of the Fundamentals of Engineering Review course that the College of Engineering at Texas A&M University is providing for Fort Hood, Texas. We're pleased to have this opportunity to work with the training division at Fort Hood, and we're working with Mrs. Nancy Stout, and we hope that this is going to be a very beneficial series for you in your first step in the professional career. Just to give the credits here, the Fundamentals of Engineering Review series is hosted by the College of Engineering, funded by Fort Hood, and we're working out of the Office of Continuing Education. All of the faculty members that are involved with the project are from the College of Engineering except for one. We have the engineering ethics portion that's going to be hosted by Dr. Ed Harris, who is a professor of philosophy at Texas A&M University, but he's very active with our Fundamentals of Engineering program and working with the engineering ethics. We want to tell you a little bit about the course. There will be approximately 30 hours of videotapes that are provided by this review series. While each topic on the FE is important, not all the topics have the same number of questions on the exam. So the way that we have the exams review structured is that we're going to provide a number of reviews, and the material that is covered more heavily on the exam will be the ones that will have the greatest emphasis on the review series. We're planning approximately 30 hours, and what I'd like to do now is to go ahead and give you the breakdown of the videotapes and the 31 hours scattered over approximately 14 different areas. The introduction is what I'm doing for you right now. We plan to have 3 hours of math, 3 hours of thermodynamics, 3 hours of statics, 3 hours of dynamics, 3 hours of strength of materials, engineering econ, which is extremely important, but it doesn't have as heavy an emphasis on the exam as some of the other topics. We'll have 2 hours. Engineering ethics, 1 hour. Electrical engineering, 3 hours. Dr. Karen Butler, who's a professor in the electrical engineering department, is going to visit with you a little bit about study strategies and the strategies that you should follow in taking a multiple exam such as the Fundamentals of Engineering exam. We have 2 hours of chemistry, 2 hours of material science, computers and numerical methods, 1 hour, and fluid mechanics, 3 hours. So this gives you the total number of hours that we're going to have in this introductory series here, the review series, and then we also will give you the number of different topics that are going to be covered. Now, I mentioned to you that most of the people that are going to be giving the exam are faculty members in the College of Engineering, and so what I'd like to do now is to just tell you a little bit more about the people that you're going to be seeing in the review series. As I said, I'm Dan Turner. I'm a professor of mechanical engineering and have been involved with review sessions and the introductory session in the fundamentals exam here at Texas A&M for many years, more than 8 years now. My area of specialty is in thermodynamics, and so I'm going to also be taping the series on thermodynamics for you. As I mentioned, Dr. Karen Butler is in the electrical engineering department, and she's going to be talking with you about strategies. I think that this is a very important tape for you to watch because there are different strategies that you use in taking a multiple choice exam as opposed to taking a problem workout exam. So Dr. Butler has been giving this strategy session for several years to our students here at Texas A&M in our review sessions, and I think she'll give you some very helpful hints about taking multiple choice exams. Engineering ethics will have 1 hour by Dr. Charles Harris or Ed Harris. Ed is a faculty member in the philosophy department. He has written a book on engineering ethics. He has participated and team-taught our engineering ethics course that we have here at Texas A&M for all of our students. And he's also been involved with preparing some of the questions that have been on the ethics area in the Fundamentals of Engineering exam. So he's a very interesting person, and he'll give a good review of engineering ethics. Strength of materials is going to be handled by Dr. Lee Lowry. Engineering econ is handled also by Dr. Lee Lowry. Dr. Lowry is a civil engineering professor and a master teacher within the College of Engineering, and I think that he's going to be giving a total of 8 hours of presentations, because he's also going to be handling statics. And so you're going to see a lot of Dr. Lowry over this tape series, because he'll be doing at least 8 hours. I also need to give credit to him. He's also running the camera and doing all of the behind-the-scenes work here for most of the taping that we're going to be doing. Dynamics is a 3-hour session. It's going to be handled by Dr. Ray James, who is in the Civil Engineering Department. Mathematics will be handled by John Weiss. Dr. Weiss has a very strong background in mathematics and also engineering mechanics, and he has done the mathematics review for several years for our students here for our engineering review at Texas A&M. Computer and numerical methods will be handled by Dr. Bill Batchelor. Dr. Batchelor is in the Civil Engineering Department as a numerical methods expert, and so he's going to be dealing with the 1-hour presentation on computers and numerical methods. Now, this is not a software or language-oriented section on the FE or EIT. It's mostly dealing with algorithms and pseudocode and numerical methods, and so this is a little different approach that you would normally have. Chemistry is going to be taught by Dr. Mark Holtzapfel. Dr. Holtzapfel is a professor in chemical engineering, and he is an excellent teacher and enjoys doing these review sessions, so he'll be working with you for 2 hours in chemistry. Electrical circuits, Mr. John Tyler, also in electrical engineering. He is an excellent teacher and will give you a good review of the electrical engineering sections. And so these are going to be the presenters for the session. Sessions are going to be in the area of fluid mechanics and material science. Dr. Ralph Words, who is a professor in the Civil Engineering Department, will tape a 3-hour session review on fluid mechanics. And Dr. Richard Griffin in the Mechanical Engineering Department, who is a metallurgist and material scientist by background, will tape 2 hours of material science. So we feel like we've got an outstanding lineup for you. We feel like we have some excellent teachers, and we're looking forward to presenting this review series to you. I want to talk a little bit about the licensure process. You're already thinking about becoming a professional engineer if you're taking this first step and even watching this tape. There are obvious benefits, of course, to becoming a professional engineer, not the least of which is the added respect that you have for your profession if you are a PE. There are certain consulting opportunities that require you to have a professional engineering license, and so in some cases it's mandatory for your job. It's probably going to expand the scope of your opportunities if you become a professional engineer, and certainly in some instances it could mean a difference in promotion, or getting a promotion or not getting a promotion. So I don't think they have to try and talk you into becoming a professional engineer if you're already taking this first step, but let me encourage you to make sure that you do follow up with the licensure procedure, because it will become very important to you professionally in your career. Now, the actual process of the PE licensure varies from state to state, but let me just tell you in general what the two procedures are. In virtually all states, the first step in the licensure process is to pass the Fundamentals of Engineering exam. After you pass the engineering exam, then you have to obtain experience as an engineering intern. Sometimes this is called an engineer in training. And then after you obtain the necessary experience, then you have a second exam that you take, and this exam is called the Principles and Practices exam. It's the second exam in the process, and it is an exam that is discipline specific. As far as the regulations are concerned, the regulations for becoming a professional engineer are governed by the state registration boards of each state and the U.S. territories. The requirements do vary by state, but virtually all of the states require passage of two exams, the fundamental exam and the principles and practices exam. So you have to check the regulations in your particular state to see what the requirements are, but I would just mention that the typical requirements, if there are such a thing as typical requirements, you need to graduate from an ABET accredited 4-year or 5-year program in engineering. Now, ABET is the Accreditation Board for Engineering and Technology. They determine the standards for accreditation across the country, and they have visitors that visit each of the engineering programs on a regular interval and determine whether or not they meet the standards for accreditation. Virtually all states require an ABET accredited degree as the first step in the process. The next step typically for states is pass the Fundamentals of Engineering exam. The next step is usually obtain about 4 or more years of applicable engineering experience. That again varies from state to state. Not all the states require this much experience. Some require more, but this would be a typical type requirement. This is, for instance, what's required in the state of Texas for you to become licensed as a professional engineer. The final stage is pass the P&P exam, and once you pass that, you are able to obtain registration by reciprocity in most other states. Now, there are a few exceptions to this, and we probably ought to point out some of the exceptions. One is some states do not allow engineering technology majors to sit for the Fundamentals of Engineering exam. I think there are roughly 28 states that allow graduates of technology accredited programs, which are also administered by the ABET, the accrediting agency. And so roughly half the states and territories will allow engineering technology majors to sit for the exam. About half will not. This is where you run into problems here with reciprocity, is this last bullet, the ability to obtain registration in other states by reciprocity. That will not apply if you, for instance, are an engineering technology major, you pass the fundamentals exam, pass the P&P, and get registered. Some states perhaps would not allow you to obtain registration in their state by reciprocity because you did not have an engineering degree program. But what you need to do, since all the states are different, what you'll need to do is look at the requirements for your particular state and determine what those requirements are. And if you're going to meet them, or if you want to apply for reciprocity in another state, you have to look at the requirements and see if you would be able to get registered in that state by reciprocity. The P&P exam is a discipline-specific exam. There are discipline exams for chemical, mechanical, several for civil, for electrical, and so you end up having to take the particular P&P exam in your area. Now, there are some states that even require additional exams even beyond the P&P in order to get registered. Some states have unique requirements, such as California has some soils and structural requirements because they're particularly concerned about their engineers being able to design in the earthquake type environment. Alaska has some specialized requirements, so also does Hawaii. So some of the states even require you to have a second exam above the P&P for registration. But by and large, 45 or so of the states just require the passage of the FE, followed by the necessary experience, followed by the examination in the P&P in order for registration. And so in most states you would be able to obtain registration by reciprocity. Now, the organization that governs the exam administration is the National Council of Examiners of Engineering and Surveying. That's NCEES. NCEES is really made up of all of the state licensing boards across the country, and they have volunteers from all over the U.S. that help write the exams. The NCEES is located in Clemson, South Carolina. Their address is P.O. Box 1686, Clemson, South Carolina. The zip code is 29633-1686. I hope that shows up clearly on the screen. And I can also, they're also on the web, and so I'll also give you their web address, and that's www.ncees.org. I'll repeat that, www.ncees.org. And so you can also find out information on when the various exams are given, the exam dates, all from NCEES. So the National Council of Examiners for Engineering and Surveying then provides the overall exam administration. They will make up the exams, organize them, send them out to the state boards, collect them, and then they will be graded, and the state boards then will be notified of the results for the FE in particular a few months after the exam is administered. Let's talk about the FE here in particular. The Fundamentals of Engineering exam is an 8-hour-long exam. The morning session consists of 120 multiple choice problems in 12 subject areas. These are the 12 areas that we've already discussed that will be covered in the review tapes. But the exam is a tough exam. It's a rigorous exam, but it's also a very tough exam to take from a time standpoint, because you are a captive for 8 hours sitting there trying to answer up to 180 questions in a multiple choice format. You get a short break for lunch, then come back in the afternoon session. The afternoon session has 60 problems. The problems are all multiple choice, and in the afternoon you have some choices on which one of the exams that you want to take and which areas you want to take. Last year, that is in 1997, NCEES went to a discipline-specific format for the PM session, for the afternoon session. There are 5 specific disciplines: chemical, civil, electrical, industrial, and mechanical. And if your degree area is not in one of those 5, there is still an afternoon general exam. Now, you have your choice of which one of these exams that you want to take. You don't have to decide ahead of time. You could even make up your mind on which of the exams you want to take when you walked into the exam in the afternoon, when you want to take the afternoon portion of the exam. They're all together in the booklet, so you may decide to even look at the questions before you make the final decision on which exam to take in the afternoon. The reason there are 5 disciplines sections is that chemical, civil, electrical, mechanical, industrial, those 5 degree programs graduate at least 1,000 students each year, and they account for something like 85% of the engineering graduates across the country. There have been some discussion and some questions of why there aren't more. Why isn't there one in aerospace? Why isn't there one in computer engineering? Or why isn't there one in some of the other petroleum engineering or some of the other degree areas? And there may eventually be, but right now these 5 areas, discipline areas, account for a huge proportion of engineering graduates, and so that's the reason why there are the 5 disciplines. Now, if you did not fall into one of the 5 discipline areas in your degree program, there's also a 6th area, and that's the general exam. So this exam that we're covering here, and the review for this exam, is to cover the general exam. It is not our intent to try and provide the discipline-specific reviews for you in the 5 areas of chemical, civil, electrical, industrial, and mechanical. We're going to concentrate on the general for a couple of reasons. One, it's if you cover the subject material in the morning for the general, you have the same subject material that you're going to have in the afternoon for the general, and so therefore studying becomes a little bit easier. The other thing that we found is if students who are still in school or just recently out of school or working heavily in their discipline probably should take the discipline-specific exam. The statistics are that students in mechanical engineering who take the mechanical exam generally fare better than the students in mechanical engineering who take the general exam. This is particularly true for the industrial engineering program. The students in industrial engineering in the last two exam administrations fared much better when they took the IE discipline-specific test than when they took the general test previously or in these last two administrations. Pass rates for IEs, for instance, were less than 50% when they took the general exam, but their pass rates were up in the 75 to 80% range whenever they took the discipline-specific exam. So this is a decision that you're going to have to make in your study preparation, or a decision that you're going to need to make whenever you take the exam. But our intent here is to try to give you a good review session that would enable you to be successful on the general exam, but I don't want to advise you just to look at the general exam if you're able to review in your discipline areas, and you might decide you wanted to do that. Let me give you some statistics. On the Fundamentals of Engineering exam, you're going to be with an awful lot of people that are going to be taking this exam at the same time that you're going to be taking it this year. About 40,000 students and engineering students take the FE exams each year. The exams are given twice a year, in April and October generally. There are exceptions, like the November or the fall 1997 exam was given, I think, on November 1. But generally, you can look for the FE to be given in April and October, excuse me. Pass rate's about 70% for all test takers. The 70% pass rate, of course, includes some of the non-degreed engineers that may be wanting to become professional engineers. It includes engineering technology majors, includes students out of school for a long time, and includes students who are in school. And so for all test takers, the average pass rate's about 70%, but the pass rate is above 80% for students who are graduating from ABET accredited engineering programs. And so there is a reasonably high pass rate. The test is intended to determine in NCEES terms minimal competence. It is not intended to be a measure of how well you score. You're not given a yardstick or a grade based on the results. It's intended to ensure that there is minimal competence on the part of the student taking the class. Now, what do you have to have in order to pass the course or to pass the exam? You need a score of about 120 points. Now, you get 1 point for the morning for each question you answer correctly in the morning session. You get 2 points for each question that you answer correctly in the afternoon session. So there are a total of 240 points on the exam. A raw score of about 50% or 120 is generally what you need to pass. That number varies a little bit from exam to exam and varies a little bit from discipline to discipline, but generally speaking, if you get about 120 points, that's going to score you a scale score of 70, which is the minimum passing point. The morning and afternoon points are added together. When this exam was first put together a few years ago, there was some talk of having to pass both the morning exam and the afternoon exam in order to pass the FE. But the final decision was, we'll add in all the morning points, all the afternoon points. That together will be your total score, and then your raw score will be determined from that. Let's look now at the distribution. Let's look specifically at the Fundamentals of Engineering exam and the various exact number of questions that are going to be on the exam for the morning session. The 12 areas that we've talked about that we're going to give you the review sessions on include chemistry, computers, numerical methods, dynamics, engineering econ, electrical circuits, fluids, material science / structure of matter, engineering ethics, mathematics, mechanics of materials or strength of materials, statics, and thermodynamics. These add up to 120 questions. You have 240 minutes, and so that gives you 2 minutes per problem. Notice here in mathematics there are 24 questions in mathematics. 20% of the exam in the morning is in the area of mathematics. There are several of the other subject areas that are double-digit type of numbers. Thermodynamics, you have 11 questions. Statics, 12. Electric circuits, 12. Dynamics, 10. Chemistry, 11. And that's the reason why in this review session we've afforded a little bit more time to these particular subject areas because of the higher emphasis that is placed on these topics in the Fundamentals of Engineering exam. Now, I'd like to tell you also a little bit about the afternoon format, the discipline-specific format. I'm going to run through these very quickly because I know that in some cases your interest is only going to be in the general exam. However, I would like to let you know what's going to be on the afternoon exam and what the distribution of time will be and problems will be for the afternoon exam. In the general session of the afternoon exam, it mirrors pretty much exactly the topical areas that you saw in the morning exam. There are 12 topical areas, same 12 that are on the morning exam, but since there are 60 problems worth 2 points each, there are a fewer number of questions in each of these subject areas. Notice, however, that the areas are roughly halved, not quite, because there are some odd-numbered problems in the morning, odd-numbered questions. But in math, we had 24 in the morning. We now have 12 problems here in the afternoon in the math area. And so, again, high emphasis on thermodynamics and statics and electrical circuits, dynamics and chemistry, and a little smaller emphasis in areas of computers, engineering econ, engineering ethics, and material science, structure of matter, and strength of materials. And so, again, the emphasis is on the areas in this exam that will be most beneficial to you in the general area, and so these are the topics that are covered and the number of questions in each one. 60 problems or 60 questions, 240 minutes. You've got 4 minutes per problem, and so the fundamental exam in the afternoon also goes fairly quickly. Okay, in the electrical, for those of you that are electrical engineers are interested in what's going to be on the electrical section, again, in almost without exception, there are anywhere from 12 to 20 topics that are covered in each of the discipline-specific areas in the afternoon. You can see the emphasis here. In electrical, 6 problems in analog circuits, 6 problems in communication theory, control systems theory and analysis have 6, digital systems 6, electromagnetic theory and application 6, network analysis 6, solid-state electronics and devices 6 problems. So these are the primary areas of emphasis that have 6 questions on the exam, but there are also additional other problems in computers, numerical methods, computer software engineering, instrumentation, power systems, signal processing. All of these are also covered on the electrical exam in the afternoon. Chemical area, about the same sort of lineup. You've got 12 different subject areas in chemical engineering. The biggest topic area is in material and energy balances, where you have 9 questions on those. But there are also 6 questions on transport phenomena, process design, and economic evaluation, mass transfer, heat transfer, chemical thermo, and chemical reaction engineering. Smaller number of questions in computer numerical methods, pollution prevention, process control, process equipment design, and process safety. However, all of these are topical areas that are covered on the chemical engineering exam in the afternoon. In the mechanical area, there are 13 different topic areas covering topics from automatic controls to computers and numerical methods, dynamic systems, energy conversion, fans, pumps, and compressors, sort of a small section in turbo machinery area, Fluids, heat transfer, mechanical design, stress analysis, thermo, and instrumentation and measurements are all 6-question areas for the mechanicals, and then the controls, computers, energy conversion, the turbo machinery, material processing, refrigeration, HVAC have 3 questions each. But again, you've got a total of 60 questions in the afternoon and 4 minutes per question. In the civil engineering area, again, about a dozen different areas that are included as part of the civil. Heavy emphasis in water purification and treatment, transportation, surveying, structural design, structural analysis, soil mechanics and foundations, environmental engineering, hydraulics, and computer numerical methods. Those are the areas that all have 6 questions each, so those are the primary areas of interest. It's not that these other areas are not important, but the way that all of these topics were determined, as a survey was sent out to civil engineering departments, mechanical engineering departments across the country, and faculty members and department heads were asked to include those topics that they felt were important to have on the fundamentals exam, and also to weight them in their weight as far as importance to the curriculum. And so these represent the input from literally hundreds of faculty members and department heads across the state, across the nation in all of these degree areas. And this is the weighting that came back from the departments. And so these are the weightings that are applied on this exam. The exam that has the most number of topic areas is industrial engineering. I guess the industrial engineers couldn't decide that any one particular area was more important than any other area, so they have 20 different topics ranging from computers and numerical methods to engineering econ to modeling, optimization, simulation, quality management, design of experiments, material handling, production planning, queuing theory, statistical quality control, work performance and methods. You can read all of these. But 20 different subject areas, each with 3 questions each. And so the industrial is the one that has the most number of questions on it, most number of areas on it. They all have 60 questions in the afternoon, but they have the most number of areas that you can answer questions in. But despite that, as I mentioned earlier, the industrial engineers have a much higher pass rate on the IE portion of the exam than they do on the general portion. So my suggestion is that IEs consider very strongly taking the industrial exam. Even if you've been out of school for a while, it's probably easier to pick up the material that will enable you to pass this area, pass this exam in the industrial area, probably easier than going back and picking up the general. Okay, let's talk now about what you can use in the way of reference books in the exam. It used to be as long as 5 or 6 years ago, as long ago as that, you would be able to take a number of books into the exam with you. Dr. Lowry has been a proctor at our fundamentals exam at Texas A&M for I don't know how many years now, but he can remember the time when the students were bringing in trunks full of boxes and trying to sift through all those boxes and trying to find enough space to put a trunk load worth of boxes in there or a backpack full of books, a real problem area. A few years ago, NCEES changed the rules and allow you to bring in something like 10 reference books, so they still at least control some amount of books that you could bring in, but still you can bring in a lot of books as a reference book. But about 4 years ago, the whole philosophy changed, and the exam changed from a open book, open notes sort of approach to the use of a supplied reference. So the supplied reference is now the only book that you can take with you into the exam. The supplied reference includes all the material for both the discipline-specific exams and for the general exam. You are only able to use this supplied reference whenever you want to, whenever you study for this exam. I mean, not study, take the exam. You can only have the supplied reference in the room with you. Now, it is extremely important that you understand and know the material that's included in this supplied reference. You certainly don't have to memorize everything, but it's important that you know where the reference material is. For instance, material that might impact you in solving a statics problem dealing with centroids or something like this could be in the math section. So you want to be thoroughly familiar with this supplied reference, and that will be available to you whenever you sign up for the Fundamentals of Engineering exam. You'll get a copy of this, and so it'll be a book that you can use to review for the exam, become very familiar with it, and also use it whenever you're taking the exam itself. Now, the supplied reference, I will just put up here the cover page of the supplied reference, but I'd also like to show you what the book looks like. The book is published by the National Council of Examiners for Engineering and Surveying, NCEES. It's available through them, but it's also available through the state boards whenever you sign up for the exam. It's a brief document in the sense that it's only 118 pages long, so everything you ever want to know about engineering is contained in here as far as being able to test for it. Formulas, equations, things that you would need on the exam are all contained in here, or they will be contained in the stem of the problem when you're actually taking the problem. There may be some information when you're taking the exam that you don't have, and that won't be in here, but it will be placed as part of the exam question. So everything that you need for the exam will either be in this reference book, or it'll be part of the stem of the problem and the question within the problem. So the NCEES then has the Fundamentals of Engineering reference book. Information about it is included here, including the web address for NCEES that's on here, www.ncees.org. NCEES also has other documents that you can use, including sample exams, and so if you want to find out what's available to them, you could contact them on the web, and I think that you can even order off of the web too. Just to let you know what's in the supplied reference, we've copied out the table of contents for right now, if you probably don't have this in front of you. And so the first items here, units, fundamental constants, conversion factors are all included. Let me tell you about the exam itself. The exam, as far as the units are concerned, is primarily a exam that's given in SI units or metric units. NCEES made a policy ruling about 5 years ago that by sometime early in the 21st century, the entire exam on the fundamentals exam would be converted into metric units. At the present time, I'd say about 90% of the problems are given in metric units. For most of you, this won't be a problem because you have probably used these in school. Your curriculum went through and used metric units. For some of you, though, it may be a problem. If you've been out of school for a while, I've been out of school for an awful long time, I don't think metric. I think English. I think in pounds per square inch rather than in pascals. I think in degrees Fahrenheit rather than degrees centigrade. And so some of you may be bilingual in the sense that you can think equally in both systems of units, but if you're much more English engineering units oriented than you are metric units oriented, one thing that I'd recommend is you spend a lot of time on the units and make sure you understand the units. The metric system with the basic kilogram, meter, and second squared unit of, or second unit of time is a very fundamental system. It's probably easier to understand than the English system, but if you're not used to it, it could become a problem for you. So my suggestion is that you spend a lot of time on units if you're not really conversant with SI, because 90% of the exam is in SI or metric units right now. There are probably only about 10% of the problems that are in English, and if we have an English unit problem, there's also a corresponding metric problem, so that you could solve the problem 100% in metric if you wanted to. If you want to solve a few of the problems in the English system, you could do that as well. As far as all the topics are concerned here, you see the math, statics, dynamics, mechanics and materials, fluid mechanics. One thing that you might note is that mathematics contains 15 or so pages, but there are only a few pages in statics. There are only a few pages in dynamics and fluid mechanics. And so this is not a reference book that you could use to study by, because it doesn't give you any solved problems. It doesn't give you any theoretical background. What you have is just basic formulas that can be used to work the problems. Thermo, heat transfer, again, most of these sections only include a limited number of pages, and so they're just basic formulas. But it is important to recognize that you won't have any questions on the FE that won't have equations or material that is covered here in this reference book. So you will not need any other basic material as far as the test is concerned in order to solve the problems. Now, about page 80 is where the fundamentals of engineering stops, and that's where the general section stops, and then you get into the discipline-specific areas. So starting with page 82, you get chemical engineering, and then you work your way through the section on civil engineering, electrical and computer engineering, industrial and mechanical in the text. So notice that there's only 8 pages or so, 7 or 8 pages dealing with mechanical engineering. So everything you want to know about mechanical engineering is contained in 8 pages. That's not really true, but as far as this exam is concerned, that's the only material that you'll have to work with. Now, as I mentioned to you, you won't have to make the decision on which of the exams that you're going to take literally till you get in there. You can take the morning exam, see how comfortable you were with answering the general questions on the morning exam. If you feel very comfortable with that, you think you've done well, then I'd consider going ahead and taking the general exam in the afternoon. However, if you're an ME, I'd suggest that you at least look over the ME problems to see how well you think you could do on those. And as I said, statistically speaking, the students in mechanical engineering do better on the ME discipline test in the afternoon than they do on the general exam. Same is definitely true for industrial. Same is true for civil. Also, there's a very high percentage difference in pass rates between the civil engineers taking the civil engineering exam and the civil engineers taking the general exam. So the decision is yours, though, and so that'll be something that you will have to decide. Now, as I mentioned, the supplied reference here is only going to be used during the exam. It's the only booklet that you'll have available to take in the exam, and you will be provided this book whenever you go into the exam. For instance, if you use this book to study by, you write a lot of notes in it. Some people have indexed it to make sure they know where everything is. Unfortunately, you will not be able to take that into the exam with you. You'll be given a nice, clean, fresh copy whenever you go into the exam, and so you certainly should use this to study by, but you don't need to use this, or you can't take your own copy into the exam. Now, for most of you, it probably would be in your best advantage to get a review text that would provide a little bit more information in depth in your area. It is prohibitive to think about going back and study 40 different subjects, but there are a couple of review texts that are available in the literature that I think would be very helpful to you in helping to prepare for this exam beyond the reference book. I'm not trying to plug any particular type of text, but I will mention that we have used 2 different textbooks here in previous times reviewing for the Fundamentals of Engineering exam that we provided to our students, so we provided to faculty in the advising in the review process. The 2 books that I'm holding up here are Fundamentals of Engineering by Merle Potter. It's FE EIT review for the A&M and for the general portion of the exam. And then the EIT review manual that's published by, a review book that's published by Michael Lindbergh is also a very good text. Again, I'm not trying to plug either of these, but I know that these two texts are available. We've used one of them or versions of both of them at different times throughout our review here at Texas A&M. And they will give you a little bit more in-depth knowledge, a little bit of theory, a little bit of solved problems, sample exams, that sort of thing, that it is better review material than just looking at the supplied reference, because the supplied reference has no problems, just formulas and equations that you would need to be familiar with. In addition, Dr. Potter has published a discipline-specific review book in 4 subject areas: chemical, mechanical, civil, and electrical. He does not have one, at least at this point, in the industrial engineering area. So if you're interested in this book, there's a possibility that you might want to take the discipline exam and you might want to review for that. So this one is also available. The Potter book is published by Great Lakes Press. The Lindbergh book is published by Professional Publications. They both have websites, and so I think you can order from them over the web as well if you want to order additional books for review and study. And I'd recommend that you do that, because I think just looking at the reference manual by itself is probably not going to be adequate. Okay, what I'd like to finish up with in the next few minutes is just to perhaps give you some hints that I think are going to be helpful to you as you prepare for the Fundamentals of Engineering exam. Number one, I think become familiar with the supplied reference is really key. You really don't want to waste time trying to thumb through that supplied reference looking for an equation that you know is in there someplace, but you just can't put your finger exactly on where it is. So I think the first thing that I would suggest is that you become thoroughly familiar with the supplied reference, know where the formulas are for mathematics and differential equations and the things like this that you're going to be using, and so that way you don't have to spend a lot of time thumbing through the reference looking for equations. There are a number of sample exams that are available. NCEES, you can order from their webpage. They have sample exams in the discipline areas and sample exams in the general areas that you can take. You can also, in both the Potter book and the Lindbergh book, there are sample exams that you can take in there. I think it's important that you take the sample exams for this reason. You want to determine the areas that you do best in, and you want to determine the areas that are your greatest weakness. This is important in the test-taking strategies and the way you'd approach the exams, but you want to find out just from you may already know where your strengths are and where your weaknesses are, but you might want to find out from the tests exactly where your strong suit is and strong suits and where your weak suits are. I would suggest that you set a goal of roughly a minimum of 60% competency, that is 60% of questions that are answered correctly on the sample exams. Well, why 60%? Well, remember that on the average it takes about a 50% pass rate in order to score, pass the exam. So 120 points out of 240 total points is generally enough to pass you. So if you set a goal that you're going to have at least 60% competency in all the subject areas, then that should give you a nice cushion above the minimum 50% that would probably be the pass score. Now, another thing that you're going to have, if you find out that there are some areas that you just don't have any background at all in that are on the exam, you're not certainly probably going to hit a 60% competency in those, and so to make up for that, you've got to have an 80 or 90% or 100% competency in some of the other areas. So I'm just recommending that as a goal. The 60% answered question correctly will be a good goal. Okay, once you've then determined which of the areas are your strong areas and which of the areas are the weak areas, then go into the exam and start with the areas that you're strongest in and work through the exam from strength to weakness. Too many times when we go in to take a lengthy exam or a multiple choice exam, We start with question 1 and work through question 140. Well, that can be a disastrous approach for something like this FE, which has a large number of topic areas, and has some topic areas that have many more problems in it than other areas. And so if you have studied and reviewed and you know where your strengths are, go right to that. If you're strongest in engineering econ, go to engineering econ, and that would be the first area that you would tackle. If you're strongest in math, go straight to math and start working the math problems. And so determine before you go into the exam which areas you're best in, which areas you're weakest in, and try to make sure that you work through all those areas that you feel that you're relatively strong in. Make sure you get through those problems. It may be that it won't even matter to you if you get to an area that you have done poorly in on the sample exams. That may not make a difference to you on the FE overall if you've started with your strong areas, done well, and moved through the exam in the areas of strongest to weakest. In the mornings, if we go back to the morning session, don't spend any more than 3 minutes on any of the morning questions. Or if we're talking about the afternoon section, don't spend more than 5 minutes on a PM section, on a PM problem, unless you're just on the verge of getting a solution and you know that 30 seconds more you'll finish up. The reason is pretty obvious. You've got 2 minutes per question on the average. Some of them are going to be 30-second questions. Some of them are going to be 5-minute questions, because there's no way that you can design problems that are going to be just specifically a 2-minute problem. But what you don't want to do is kill a lot of time on problems that you're having difficulty with. So spend up to 3 minutes on a morning problem. If you can't get it, mark it in your book that you can't get it, move on to the next one. And do the same thing in the afternoons. Don't spend more than 5 minutes on any of the PMs. Now, you have 3 hours or you have 4 hours to take the exam. Generally, the proctors in the room will give you warning as to when the exam is about to finish up. You'll have a number of warnings throughout the afternoon, but typically at about the 15-minute point is where I would I'd stop answering the questions and actually working the exam, and I'd go back at this point and go back to any questions that have skipped. Questions that you were on the verge of finishing, or questions that you think that you could handle. I'd go back and I'd spend about 10 minutes trying to answer these questions. It's possible in the morning you might pick up 4 or 5 additional questions in that 10-minute period of time, because you'll come back with a fresh perspective. You'll come back and look at problems a little bit differently, and very likely you'll be able to answer several of the questions in this last 10-minute period of time. At the 5-minute mark, I would go in at this point and just fill in all the unanswered questions. Go ahead and guess. This is an exam unlike some of the standardized exams that you may have taken for college or for graduate school. There's no penalty for wrong answers. So it's not a right minus some percentage of wrong, or right minus wrong on the exam. Go ahead and guess. It's perfectly all right. Use whatever guessing scheme you want to guess, because it's not gonna hurt you. I have a good friend who is not an electrical engineer, so when it comes time to start doing his guessing on the electrical engineering problems, he's got a very good solution. He answers them A, C, DC, AC, DC, and down the line, and that's his solution to answering the electrical engineering problems. You all can be a lot more sophisticated than that, but that is his approach. This concludes what I wanted to talk with you about on the exams. Remember that you can contact NCEES at their website at www.ncees.org. Texas A&M also maintains a website for engineering registration, and that website is called Engineering Registration, no spaces, all one word, engineeringregistration.tamu.edu. So you can look up the latest information on engineering registration at our TAMU website. If you want to do that, Dr. Lowry maintains that site. And I wish you all the success in taking this Fundamentals of Engineering exam. I would like to get feedback from you on the usefulness of the tapes, how good the sessions were, how much they helped you on the exam. And so we'll try to provide some information later on for you to contact either me, Dan Turner, in the Mechanical Engineering Department at Texas A&M, or Dr. Lee Lowry in the Civil Engineering Department at Texas A&M for any comments that you have about the tapes and the review process. So I've enjoyed working with you on this segment of the review session, and I wish you much success as you complete your reviews and as you take the Fundamentals of Engineering exam. Thanks.